Okay, so this is another installment of the Tech Talk for the Campus Champions program. My name is Jeff Pummel. I'm the co-director of Arkansas High Performance Computing Center. And this particular presentation comes from the recent survey that was sent out about scientific software and tools that people wanted to learn more about, both as a tool for use as well as setting them up and using them in a high performance computing environment. Today we have with us Jonathon Anderson and Brett Shouse from University of Colorado Boulder. UC Boulder has been doing a lot of work in this area since they were kind of pioneers in setting up Jupyter on HPC, and I was really fortunate to be able to get them for this presentation. So in just a second, I'm going to turn it over to Jonathon and Brett, and we can take questions along. It may be easier if you raise your hand or put something in the chat box, but I can kind of defer to Brett and Jonathon for that. But without further ado, I'm going to go ahead and turn it over to the guys, and we'll get started. Brett, Jonathon?
Yeah, I've got the chat window open over here too. So if questions come in, we'll try and notice that. And there's two of us, so I'm sure one of us can notice that. We set up Jupyter Hub on our environment like 3 years ago, and it has never really taken off as a primary interface into our environment, but we're hoping that changes. Brett came on a few months ago. We're kind of throwing all that work his way, and the people that use it like it a lot. We've just never really advertised it as a first-class service because we haven't had someone whose job it was to make sure it's kept working. So we've been updating it and kind of improving the way it's deployed to make it more serviceable recently, and Brett's been doing pretty much all of that work. He also did most of the presentation, so I'm mostly just going to shut up and then throw comments from the peanut gallery as we go. But Brett?
Thank you. My name is Brett Shouse. I joined RC about 2 months ago, and I'm working on Jupyter Hub. And today I hope to speak with all of you, share a little about Jupyter, how you can use it, where you can use it, and why you'd want to use it. Please feel free at any time with questions. I don't mind being interrupted. So with that, let's talk about what is Jupyter Hub. So Jupyter Hub is an interactive environment, a living notebook where students, faculty can write a story, tell a story about data, about code. It lets you mix together your text, your media, your program, your graphics, whatever that may be, into a single long or short book that you can share with people that can follow through and understand what's going on. There are many computational notebooks available out there. You can do it for C, for R, for just about any language you want, of course, Python. The beauty of most of this is it's shareable. You can take what you have, send it over to a friend, and they can run it and see that same kind of output, understand that story, and follow it. And not only do they get output, but they get interactive output. They can see what you've done. They can try to change numbers and rerun it and get something different, or modify it to fit their needs and make it work for them as well. So it can be that interactive two-way conversation that you have with someone in a real shared environment. And then, nowadays big data is everywhere. You can plug this into GPUs on the background, huge data stores, all sorts of information, so that you can do whatever you need within this Jupyter notebook, this interactive living communication medium. The notebook themselves come with hundreds plus kernels. These kernels let you run all sorts of programming languages, RStudio, MATLAB, Visual Studio Code. So if you need to do statistics or software development with debugging, this all runs within Jupyter, so you can just set it up. Your students or faculty don't have to worry about how it works, how their computers are, if their hard drive crashed. You offer this out to them and they have everything they need to do their class today without all the spin up and setup. So that's the what of Jupyter Hub.
Oh yeah, I took some screenshots here of what it looks like just in case anyone hasn't used Jupyter or IPython notebooks or anything like that before, this is the old interface that we've been running for a while, where you get like a file browser on the left, and then when you open a notebook, you get effectively a line-based text editor, but with it's really more block-based. So this here is a code block, but you can have like markdown blocks or text blocks or image blocks, things like that, that might be generated from other blocks. So a common thing that you'll see in our demo later is like you'll have MATLAB, or not MATLAB, you can do MATLAB code too. I'm trying to say matplotlib code in a in a code block that will generate an image that'll show up later in the document. This is the new Jupyter Lab environment that is replacing that notebook environment. Really, the Jupyter project's been around for a long time, and it's been evolving quite a lot. And this was an effort to just kind of take a step back and reevaluate the way people were actually using it, especially in light of Jupyter Hub, and make it a better first-class interface that's really more like an IDE than what it was before.
So why would you want to use Jupyter? Even on your local machine, it gives you everything self-contained right on your workspace so that you can tell that story. You can massage the data, the code, to draw that picture that you want to picture for your audience, or for a teacher to teach the class and help the students understand the flow or the logic that is put forth in a notebook. Each of the workspaces is fully customizable. So if you're doing something in Python, you can have a Python environment. If you need something in C, you can have a C environment. It doesn't restrict you. It's free to be what you need it to be. In a more institutional place, hosted environment, you get all the advantages of that local machine, but you get a little more control. You can do pluggable authentication so that you're ensuring just your students are using it. You can control what software is running in that Jupyter instance, or you can turn that control over to your instructors, excuse me, so that they can develop what the environment they need for their class. It offers data sharing, so if you have a big data, you don't have to take that whole chunk of big data and copy it to every student. You can host it in a central repository. Every student gets to share the same data. Everyone's working on the same page. And then a big one when you're working in a hosted environment is your resources. You can control how much CPU, RAM, what GPUs, how much storage is available to your users. So you don't have to worry about someone going in there and spinning up 20 GPUs or someone accidentally starting up a Bitcoin miner and running up your bill. These limits will help make sure that you can cap what they're doing and keep things under control while you're helping everyone else.
Yeah, when we first started with Jupyter Hub, most people were already running Jupyter notebooks on our infrastructure, even on the HPC system, by submitting a job, usually an interactive job, I think, and then running the notebook manually from the command line and then port forwarding it through a login node. And it was just a whole mess to get it to work. There are still people that are doing that today because we haven't been supporting them quite as well as we are intending to. But I wanted to be using Jupyter notebooks just because they seemed like a good idea, but I hate running web services on my desktop and connecting to it with a browser. And so I was looking for a way to host it. And it was said earlier that we're pioneers in this. I really don't think that's true. The pioneers are the people that are building all this code. We're just some of the first users of a lot of it. And we found, oh, look, someone is finally building a service to run this. And oh, look, someone is building code to glue it into a queuing system. So we've been chasing that development, and it's really worked out well for us.
So I don't know, excuse me, if anyone's really particularly interested in the architecture, but from a tech point, it's very, very simple. At the top, you see an HTTP proxy where everyone comes in, all their requests, they go to the hub, and the hub authenticates them, connects to the database for information. You have your config with details about where your SSL certificates are, but generally the flow is that HTTP proxy to the hub to the spawners. And those spawners are what kick up your instances for your users to use. So in the case of HPC, we see that going out into our cluster, and running the container that they need or the environment they need to do their work in. As we talked earlier, the authenticator can be single sign-on. I believe here in the HPC, we have it backed up by Duo as well. So we have got some two-factor authentication behind it. Of course, in our config, everything's SSL. Then we give users a couple options for what to spin up in their spawners over here on the right. But generally, it's a proxy that connects them to their spawned lab where they can do the work that they need to do.
Yeah, also generally, it's not actually as complex as it looks here on this diagram. Like even the database is just an SQLite database that's sitting on the same host. This is all pretty straightforward to build and get running for what it's worth. So this one's me. And I meant to go back and add one more thing to this. So the thing that makes it different when you're running it on an HPC environment is just getting the tasks to run where you want them to run. So Jupyter Hub comes with a local spawner by default where it just runs user notebooks as processes on the server that Jupyter Hub is running on. There are other similar alternatives. You can get like a Docker spawner that runs them as local Docker containers, sudo spawners to do things as other users and stuff like that. But we started using what was originally called the Slurm spawner, which was nice because we were using Slurm, but has since grown to support, I think, pretty much every batch queuing system you would care about as the batch spawner. And this is just some code that I think it's in IP and all of that. You can just install it now. And it just plugs in into the config file as this is how I want to run my spawner. I've got some examples of what the config looks like in a moment. And then we wrap that with a profiles spawner that lets the user, when they log in, select what kind of environment they want to be running in. And this is one of the first real limitations to Jupyter Hub right now that we're running up against, where we might actually finally contribute some development. But right now, Jupyter Hub only supports like one input when you're logging in, and that is how you select which profile you want to run. But the downside to that is if you have to like predefine all of the permutations of the types of environments you want to run. So we're hoping to contribute some improvements there, where you get more of an entire form of I want these nodes on this cluster and things like that. A big change for us recently that's improved the service a lot is dedicating resources to Jupyter Hub explicitly. So we only have 2 nodes reserved for it, but we massively oversubscribed them at 4-to-1. So you can get 4 times as many users running in those 2 nodes as we have cores in those nodes is the idea. With the thinking being that for the most part, people aren't really trying to max out a node or even a core when they're running a notebook. They're just trying to get interactive access right now. And then if you do need dedicated access, you can use a different profile and get a whole node to yourself in the general queue, but then you have to wait for that to start. For the most part, those run as a single task on a node or a set of, a node or a core. But there are options for running distributed tasks as well. The first one that we deployed was IPyParallel, which still has first-class integration with the legacy notebook interface, where you could start up a cluster of IPython kernels as their own separate Slurm job that was running elsewhere out in the cluster. And then you could reference that cluster of IPython kernels to do distributed kind of MapReduce style tasks. And then Dask, which I don't know that much about, appears to be doing roughly the same thing, but it appears to have better first-class support for the queuing system itself, kind of wraps that entire workflow, whereas you had to use Jupyter Hub or Jupyter Notebooks to do that before. And that has first-class integration with Lab Hub, I believe is what we've seen, and that's set up. The one thing that I forgot to put here is that we've also used MPI for Pi in this environment. And the way we did that in the past was just had MPI for Pi loaded in the IPython kernel environment that was started up by IPyParallel. And so what you ended up doing was starting up a cluster of IPy kernels elsewhere in your cluster, but then you could run MPI for Pi native operations against them. And we had that proof of concept working. I don't know that anyone is actually using that today or really has used it outside of our tutorials and classes, but it's something that we have the capability to do if someone wanted to actually do real distributed computing with the notebook. For the most part, it's about ease of use and accessibility more than it is true computation, but it's there and it's possible. So this is an example of the spawner interface with our default interactive profile. This gets you a 12-hour job with, conceptually 1/4 of a core on our interactive resource. And then the config for it is super simple. We started splitting the actual job script out to make the config file not get so huge, but you just say what your job script should look like that Slurm will run, and then some arguments that get plugged into it for what partition you want to run on and other things about the job. And then that's just a standard Slurm job. If you've done Slurm jobs, this doesn't look too weird. It just defines the resources that you want your notebook to run in with some variables that get plugged in at submit time. And then we do a little bit of setup here to initialize the user's environment with some defaults if they don't have an IPython environment, or to customize the Jupyter environment. We're doing that for a few users that want like shared group spaces. This lets them put their kernels in that shared group space, things like that. And then, load Anaconda and start Jupyter Hub. Yeah, it's been pretty straightforward, and the examples in the documentation are pretty good too.
So I'm going to talk a little bit about if you want to deploy Jupyter in the cloud instead of the HPC. Basically, you've got quite a few options out there. It's growing every day. But if you want to set up something managed, have someone else take the bulk of the headache, there's services out there like Microsoft Azure has a notebook service, CoCalc does a lot of notebook services. If you're doing Elastic MapReduce, AWS has an Elastic MapReduce Jupyter notebook, so you can crunch your big data there. As far as going self-hosted, it's recommended. It's faster, cheaper, better. There are lots of guides out there. Zero to Jupyter Hub with Kubernetes, if you need something to support a whole campus, is an excellent guide for technical staff to spin up a cluster in any of the major cloud providers. If you need just a single instance, you've got a big server and you want to run Jupyter Hub for a class, the littlest Jupyter Hub is a great guide. Walks you through how to set it up, how to control resources, authentication, all sorts of different corner cases, so that you can basically have a horizontally, or excuse me, a vertically scaled Jupyter Hub, whereas your Zero to Jupyter Hub with Kubernetes is going to give you that vertical scaling where you can grow with the cloud instead of be limited by that single instance machine. Some of the things we've learned along the way, resource limits are important. Especially with your CPU, it's important that you grant every user a minimum. They're guaranteed this amount. And then we like to let the upper limit be fairly free or at the maximum of the machine. This allows users, if the server's packed, everyone gets their quarter CPU or whatever it may be. But when the server's empty, if someone's sitting there and wants to do a big computation, they can burst and use all of that excess CPU utilization, so all that extra CPU cycles, so that it's not being wasted. If you set the minimum and the maximum to the same, even if there's just one person there, they're always going to be limited. So it's a good idea with that CPU limit, if you can do it, give them a minimum guarantee, and then let them burst to the maximum of the CPU. If 100 users are on, they'll never get more than their minimum. If they're the only one on, they'll get everything the machine has to offer them. They can get their work done quick and get out. RAM limits are a little more, especially in a Kubernetes environment, are a little more risky. You definitely want to guarantee them something, but if a container reaches its RAM limit, it'll actually get killed. So you do want to put a RAM limit there, but it needs to be a reasonable limit, because if one student is doing something that's reasonable and they hit their RAM limit, their container will be killed and they have to start over. So a little gotcha there. You want to be careful about that RAM limit and the CPU limits give them some freedom. As for storage, again, this is more in the Kubernetes environments where you're doing scaling stuff. Be aware that block devices are generally limited to a single availability zone. So if you're trying to do something high availability and you're doing something in the east and the west just to make it easy, block devices that were available in one zone are not going to be available in the other. So you want to be careful and plan and make sure that those block devices are, that's considered when you're setting up cross-zone availability or cross-region availability. There's also a block devices per node limitation. So a lot of people like to set up, I just want one big machine and I'll put everyone on it. Well, if you have more than, I think it's 25 in Amazon and 100 users in Google Compute, you'll run into these limits, and no more than 25 or 100 users will be able to attach to a node.
Yeah, but these are constraints that really are more about the limitations in the cloud environment that you're running in, right? And on the central. In the central environment that we're running in, logging into this looks pretty much exactly like logging into one of our login nodes. So you just have access to the same NFS shares that are mounted and with the same permissions. Your notebook runs as you, so there's no difference in terms of your access on the central on-prem thing. The other thing that we should mention with storage is that there are first-class plugins available for other storage systems. So I know you've been working on Google Drive integration.
Yes.
For bringing in just the ability to access your Google Drive share, which really makes sense if you have like single sign-on. We're using that for our classroom environment, where students just single sign-on with their Google credentials that they get through the campus Google instance. And in theory, at some point, we'll then have access to their Google Drive and can store notebooks in there as well.
Yeah. That's a good point. I'm sorry I didn't point it out. This is more your cloud-based hosted best practices. Yeah. I'm new to the HPC area, so I'm skirting that. But if you do have questions, I'm sure between Jonathan and I, we can answer some questions on it. As for software management, you can centralize it immutable with a Docker file if you want to give professors, teachers more flexibility, let them roll out what they want. You can use a binder hub that will allow everyone to define their own environment and spin it up. We talked a little bit about profiles in the HPC, and it really comes down to there's no one size fits all. That customization is important, whether it's giving control to an instructor or creating a per class Docker. It's going to behoove you to keep those customized.
Yeah, and the way we've done that so far, because in our experience, people who want to use this or especially if they want customizations, they've probably already been using Jupyter notebooks locally for some purpose. What we've been doing is just asking them to give us an example notebook of everything they want to be able to do. And then we use that as our test plan. And we just bring that into the profile that we're developing and make sure it executes. And it's been a really good way to kind of share expectations and make sure that we're meeting what they want to be able to do in their environment.
All right.
All right.
Any questions at this point? Now would be a good time before we start running through the...
I think is this our last slide too? There's two more.
Yeah.
Okay. So, switch over to, oh wait, it says I'm muted, what?
Oh, sorry, that I bumped the wrong.
We've been talking too long.
I have a question here.
Yeah. Absolutely.
Yeah, this is Chris Pachorik at UC Berkeley. We've been running on our campus cluster Jupyter Hub, I think in a similar way. I'm not a sysadmin, I'm a user consultant and a statistician, but our sysadmins here have been pretty frustrated with the batch spawner, and I'm not sure I have my hands quite on exactly what the issues have been, but I think some of the things that have happened are, for example, when a user tries to start up a notebook and spawn their session, that if the partition is full, they often don't get useful feedback back on what went wrong.
Yes.
And then sometimes if things have gone wrong, like the file system is slow to respond, then it can be that the notebook is slow to start up, and then Jupyter Hub sort of fails out without telling the user anything. So I know that's a little bit vague, but I think the general thing has been that if sort of things go wrong in some way, the user often doesn't get useful feedback on why their session won't start.
So one of the things we did to remediate that was to make sure that the job that is getting queued writes a log out into the user's home directory. And that doesn't make it very obvious, but if someone says they're having trouble, we can point them to that or ask, or we can look at it. It is at least a place that the user has access to see what's going on. That doesn't help if the partition is full, like you said, and the job doesn't even try to start. For the most part, we've tried to remediate that by dedicating resources to it, and we're dedicating more resources than we see load. So if people are just running in the default profile, then that kind of issue doesn't really come up. Where it does come up is for the user who is willing to wait for dedicated resources. But right now, I think our config is timing out at like 5 minutes or something like that. And if you have to wait longer than that, then it just dies. And I don't remember if that's a configuration limit or if it is an actual limit in the code or something. But you're absolutely right that it doesn't provide you much feedback. It would definitely be nice if the batch spawner were able to give the hub itself information about the state of the spawn and could say, you are queued and you're waiting behind this many people, or it's going to take this long for it to start, that kind of thing. There's nothing like that today. That's absolutely true.
Thanks.
But we're also lazy webbing it and just hoping that someone else will do it. So I have an instance of the Jupyter Lab environment pulled up here that I'm logged into. This is the most recent iteration of the local deployment of this that we have that will hopefully soon replace our previous one that is being held together with wishes. But yeah, I have an old notebook pulled up here that we were using for a tutorial that was just like an intro to using Matplotlib with it. And as you can see here, we've got like some markdown cells. If we double click into these, you can see the actual markdown, but they render like this. So the goal is that you would be able to have something that looks like a halfway decent document, but then has live code in it. So we've got links in here. But then down here we have code that that generated output, and we have code that generated a plot, things like that. I haven't rendered this in this environment, so we're going to see if it renders and succeeds. We're getting an error. So yeah, this is a notebook that was written in a previous environment.
We're missing a definition somewhere. We probably didn't import something.
Oh, I just need to say like do all of them. Yeah. Yeah, this one was rendered in another environment, and it just doesn't have things pulled into it. But in general, you have code blocks and you get output, and sometimes that output is text, and sometimes that output is an image that the notebook knows how to render. Simpler examples, if I do a new Python 3 notebook, you can do really dumb things like just like a hello world, and then you get output if it's going to run. Yeah, there we go. And you can do pretty much any Python or IPython-y thing in here. Or as you saw, there's other notebooks as well. I'm glad to see that we have Bash notebooks. This is one of the things that shouldn't be as cool to me as it is, but the fact that you can just put shell-isms in here and get output has been a really interesting way to provide documentation. So for some of our classes, we'll give notebooks out of the examples, and then that just becomes living documentation that our end users can mess around with and see how things change right there in the same document that they're getting the information from in the first place. I think I can even run like SQ in here, yeah, and see the state of the queue, which leads to another thing that I really think is surprisingly good, which is there's a terminal emulator in here. And so we can get a terminal just on, this is a compute node, but it's a normal webby terminal thing. And for a not insignificant portion of our user base, logging into a web page that has a username and password field And then opening a terminal in here is more straightforward and less intimidating than being told to go get putty and run putty on their Windows machine. And if nothing else, it makes an entire tutorial environment, even for terminal-only tutorials, it makes it all the same. So you're not having to say, oh, well, you're on a Mac, so open terminal, and you're on a Windows machine, go get putty and run this. So you're on Linux, you probably can do it anyway. You can just say, go to this URL and log in, and it will work. And then people who want to divert from that can. But you have a baseline that will pretty much work everywhere. What else should we talk about in here?
I was going to also point out in the interface, we got our file browser over here. You mentioned Dask was.
Yeah.
So in here, you can spin up a cluster. These are, on the left hand is the first-class citizens, I would say. It's got a file viewer, so you can just navigate files. If you want to upload in here, you can just drag and drop files in. Right-click to download. So it's kind of got a very modern, intuitive interface.
Oh, that didn't. I'm not in the file browser.
Not in the file browser, yeah.
I just tried to drag and drop something and I did it in the wrong place. Here we go. Let's put an image in there. There, it's there. Done.
Yeah. And so it has that, for even people that aren't computer scientists, that has kind of a very standard feel for it. You don't have to worry about finding the right upload location, drag and drop it in. So you can target more than just your computer scientists or your data scientists. We're looking to use this for an English class. They're going to be doing topic iteration. I'm sorry, I'm not an English specialist, but they're going to be doing something Englishy in here, tearing apart books and analyzing their text. And so these are people that don't have a lot of necessary computer science skills, but this gives them an environment where they set up, run, and go. There's no more local install. As long as you have your web browser, you could get in here and go. Something else that's, I think, fun about it, interesting about it, if you need more kind of complex workspace, you need to adjust things, this also tabs out, arranges things, so you can have multiple bits of data on the screen. And again, this is great for storytelling, great for visualizing, helping people understand what's going on. You can have your data file open and look at it, have your actual spreadsheet up, even an image loaded, whatever you might need, tiled onto the screen so that people can learn how they learn, interact with the system, and not worry about the setup.
Yeah, this MDI interface specifically is one of the big wins of LabHub over the previous notebook interface that had just kind of grown up from it being run locally. But the other thing, like we were just talking beforehand, that I'll be writing a Python script or something for a report that we're doing because I do it in scripting, because why not? And a benefit here is it just really tightens that like develop and iterate and run and get feedback loop. Whereas what I'll traditionally do, and what I'll still do out of habit, is have a text editor and a terminal running and edit over here and see my output over there. But the fact is, if I got in the habit of it, and especially now that we have resources dedicated to it, you can do that all in one interface, and it's very easy to kind of make modifications right in the middle of what would otherwise be a script and just rerun the parts of it that apply to your change. We have a question over here in the chat, which is, can just about any notebook developed in Jupyter be dropped into Jupyter Lab? If you are already using a Jupyter interface today, the only thing that would be different is just, does the environment that you're running it in have the same packages that you need or the same modules available? So as long as you can bring those in, like there's nothing special about, there's all kinds of like conflicting words here. Jupyter Hub is how we refer to the service because that's how end users are coming to it. But ultimately, it's just running Jupyter underneath it. And this is the latest iteration of Jupyter, but it's the exact same code you would run if you were running it on the desktop. There's nothing special about the fact that we're running it in Jupyter, underneath Jupyter Hub. So yeah, they should be completely compatible one way or the other. That's kind of the point. Brett has typed into the address bar here. Here's the old interface, and we can still access this. In fact, I think that running notebooks are still shown here. And so we had that matplotlib one open before. If you're used to running this or you've been running it on your desktop for a while, this is probably more familiar to you. And this is still running on that same compute node using the same web server proxy. It just, it's the older interface. Yeah, any other questions that we can, happy to talk about it also. What versions of Batch Spawner and Jupyter Hub are you running in production? As far as I can tell, Batch Spawner went out of sync after Jupyter Hub release 1.0 and has not gotten back into production ready state yet. I think we're just running the latest of everything, right?
The latest of everything. We can look up the versions.
Yeah,
but
we had some tiny problems with Batch Spawner for a while, where I never really got a good explanation for, or convinced myself what was going on, where it was like it wasn't rereading the config file or something. But for the most part, we haven't noticed any problems with it. And since we haven't had any problems, I haven't gone looking into the development state of it. But yeah, we're in this environment that we're showing right now, which technically isn't our production environment, but it's definitely better than our current production environment. It's running the latest of pretty much everything.
It's running out of the Git repo effective 2 weeks ago for
Batch
Spawner, Jupyter Hub 1 and Jupyter Lab 1.1.4.
One thing that is worth talking about is, contrary to what we were doing before, all of this is running primarily out of Anaconda now, whereas before we were being sysadmins instead of end users, and we had run everything in like a virtual env that we were pip installing stuff into, but people just really expected Anaconda. And so we have this all running out of Anaconda now. You may have noticed that the script that starts this notebook loads Anaconda and then loads an environment there and runs Jupyter Hub out of that. One of the big wins there is it means any of the kind of native, the way people expect to be able to create kernels just works now. So if they have kernels set up in their environment, if they're using Anaconda, even if it's not our Anaconda environment, those config files get picked up and noticed and appear in your list of possible kernels. And then I think they get picked up. Well, I'm going to go back to the other environment. Let's see if this breaks this time. Is it just hub, right? Lab. If you go new notebook, those kernels will show up here. And I think they show up, in this list if you want to change those kernels. If you have custom kernels with custom packages, for the most part, our end users don't really have to ask us to install packages anymore because they can just put them in a custom Anaconda environment, is that what they're called? And then create a kernel around that. And then those kernels are what actually run the code in the notebook. So for the most part, people don't have to care what the environment is the hub itself is running in. All that matters is the environment that the kernel is running in. Now we have many more questions. So was user authentication tied into any other user management system, or was it all through Jupyter's internal user management? So ours, historically, the internal one has gone through PAM, which itself is hitting a Duo authentication proxy that hits AD and Duo. I think that's still the case for this one. The cloud one is different. Do you want to talk about how authentication is working on the cloud?
The cloud's just using OAuth right now because we're Google campus. Students use Google. We're using Google OAuth to authenticate them. Yeah.
So users get auto-populated in Jupyter's internal database as they log in, but those credentials aren't stored there. Those are mostly just for session management. Since everything is run in the browser, does that mean that we could potentially run a Jupyter notebook from a Raspberry Pi? Presumably. You could probably run the server on a Raspberry Pi. Probably different Raspberry Pis, but yes. Are you running the default proxy? With larger classes, we're seeing performance issues or timeouts with the JHub proxy. Did you try the new traffic proxy yet?
We have not used the traffic proxy yet. I think we've maxed out around, in my experience, around 5,000 maximum users, and the default proxy has been working for us. So,
and that's in the cloud environment. On the internal one, it's way tinier. But again, same thing as with Bash Spawner. We haven't noticed a problem, so we haven't gone looking for solutions. But it sounds like you know about the traffic proxy, and yeah, I have not heard of that before, but that's why it's not my job anymore. Some things were answered already. Do you happen to know if NBGrab or NBGrader, yes, or some way to push files to user accounts exists with Jupyter Lab? I know Thomas has used NBGrader before in the kind of manual way of doing it. I don't think we have that integrated into either of these environments yet. Right?
Into LabHub, NBGrader's there, and it just works the same way. Okay. When you start up, NBGrader pulls the environment. Basically, you give it a URL, you click on that URL, it comes into Lab and pulls that environment in at the same time. So I'm not sure if I answered the question. Yes, Lab still and NBGrader still work together.
Does that have a way to push files out to user locations? I think that's why we've been looking into Google Drive to try and do more shared file stuff. Or does NBGrader let you? So
NBGrader is going to pull a GitHub repository or pull something into the student environment. If they need to push something out, generally we add Git as an available service so they can add a repo and push it back out.
Okay. Any comments regarding my binder for deploying Docker-based Jupyter environments from a GitHub repo? Love the concept. It can be very slow to build and deploy.
Yes.
And it seems that we have the same feelings. This is another thing that I have not used, but that is what I've heard as well.
So in the HPC environment, I don't think we've worked with Binder Hub or my binder much at all. For internal deployments, internal systems, yes, LabHub uses it. It is slow. We generally try to pre-build images. That way when people hit it, they're getting a cached version instead of trying to build it live at the time. Not in production here. It's one of our next steps for our LabHub environment.
Yeah, the current milestone has been build up an environment that supports 2 or 3 early classes, see that it's fine, that it scales and all of that. That's the one that's running in AWS. And then I think Binder Hub was on the list for the next iteration when this semester rolls down, because we didn't want to mess around with it too much when classes were depending on it. How does Google Collab come into play? What is Google Collab?
So Google Collab it's basically a modified Jupyter environment.
Okay.
It's a place where if you want to go out right now, any student, anyone can go out, log in, they'll give you 1 free GPU, a core, and I don't remember how much memory, but it's a place where if you want to play with a notebook-like environment and look at it, it's a good way to explore because you do have the GPU, you have CPU, and you have quite a bit of memory. There's limitations, but it's a good way to kind of see what these cloud-hosted environments look like and can do. So, if you need something like that, Jupyter Hub, Jupyter Lab, customize it up, and you've got your own Collab.
But then presumably that it is just running Jupyter underneath it, and you can take whatever notebooks you would develop there and run them in any other Jupyter environment, like this one or our cloud one or anything that you would deploy.
Yeah.
So I think that's all the questions right now. Oh, now there are more. How are you monitoring that the Jupyter Hub service is up at all times and launches successful sessions for users? Do you have an alerting system if the service were to become unavailable? And then example with... Yeah, so internally we do that kind of thing with Nagios, and we don't have a lot of per session monitoring. So our monitoring tends to be a user emailing us and telling us that it's not starting, but it hasn't scaled up very far, so that's been fine. For the cloud stuff, I know you have some other monitoring.
So we do Nagios, an uptime robot. The thing that we don't monitor that we'd like to is the API because, we'd like to make sure it's up as well. The web server will respond, but the API might not. That's not currently being monitored. Otherwise, we're in a cloud environment, so we have logs, files that come in. We get notified based on them. Depends on which cloud provider you're with, but I think Google's is StackLogger. StackLogger? Anyway, whatever their logging environments are, and we just send out alerts on those when logs come in that it's crashed, failed. And that's worked so far for us. We've had 2 or 3 reports with our new system, and every time we look at the log files and we were able to clean it up. Generally it was getting killed for too much memory or people not waiting long enough for servers to spin up. It's been very simple stuff. We haven't really ran into too many technical problems with that our logging has helped.
So someone said you mentioned AWS EMR, but any comments on AWS ECS using for deploying a Docker-based Jupyter environment, but would like to deploy on an Exceed resource in a similar way? And ECS is just
the Elastic Container Service.
Okay.
ECS, I've steered away from it just because it's designed to be, you dump your workload out there and it gives them whatever resources they need for it. So, this is great for business. Hey, I need to crunch all this data. I don't care what it costs, put it out there. And it spins up the VMs, does the crunching and brings it back. I'm a little more budget conscious. I've been using their Kubernetes Managed Kubernetes service, EKS, because it gives me a little more fine-grained control on where it's running, how it's running, what their resource limitations are. It's not to say that this couldn't be done in ECS, and in fact, the Jupyter, Zero to Jupyter Hub stuff includes a document on how to do it. I just don't feel like it's the service being used as for what it was intended for, which is get a bunch of data crunched, turn it off, and come back. EKS is more suited for this type of environment, I believe.
Yeah, I will say, I'm not a Kubernetes guy, but from looking over Brett's shoulder, it seems like Kubernetes has been a really good fit for deploying this in a cloud environment. And then we've been pretty happy with Batch Spawner in an HPC environment. So I feel like those two patterns, wherever you're getting your Kubernetes, whether you're building it yourself or using an existing Kubernetes service, that should be a good fit. And I'm an HPC guy, so running it in Slurm has been nice. We're to the bottom of the questions in the chat again.
I think that we have 2 more slides.
Yeah, let's go back to our slides. If I see more questions come up while we're finishing up, then I'll read those too. I keep getting worried when I'm clicking that stop share button that I'm about to leave the meeting. Let's see here we go. So we'll share our slides back out again. Yeah.
Okay. I guess not so important, but these are just some common use cases where Jupyter can be valuable. And as you can see here, it's not limited to CS. It's not limited to data science. In fact, I already spoke about the English department picking it up next semester. So these are across the university. Don't limit yourself to your technical people. Anywhere and everywhere, this type of environment is applicable. It removes the barriers so that students, instructors, teachers don't have to fight with every individual's laptop, make sure they get the right software installed, make sure it's powerful enough. It gives us a central way to create that environment for them, and they can use it, deploy it, and go forward without the struggle.
Yeah, it also just kind of unifies the experience, saying between things as diverse as people doing big data analysis on genomic data and people in the English department doing OCR and things like that. They all have a relatively similar experience, even if they're in different programming languages, and that, in theory, helps with self-support, where students in different environments or researchers in different environments can learn from each other's experiences. These are all positive things, in my opinion. Yeah, and we've been taking questions, so I'll leave this here. I think that's everything that we have.
Yes.
Happy to take more questions if there's more. We've got a few minutes before the actual end. That's where we are.
So now's a good time for any finalizing questions, as Jonathan and Brett mentioned. I'm certainly happy that we had, I think, at one point 76 participants for this call. It's certainly reflective of the curiosity of the community for this tool set. And I know, oh, there's another one.
Are you providing the service for free or charging? So in the internal environment, the service is basically the existing cluster. We spun up another VM that's running the Jupyter Hub itself, and we do some software management. But that's all just, there are people that are buying nodes in the Conda environment, and in theory, they're paying for it by buying those nodes. The other system is a general access campus and a few other partners thing. So there's no additional charge for that. In the cloud, we're also not charging for it today, but it's part of a pilot program. And so I think the expectation is in the fullness of time, that would be paid for with class fees for classes that are using it.
And that's for UC Boulder and or the RMAC consortium?
So the RMAC consortium stuff, we have some authentication issues getting people logged into it because we're using Exceed credentials and we don't have OAuth tied into Jupyter Hub for our central deployment. But that's not a policy thing. If we get the authentication sorted out there, we would make it available to RMAC people as well, with no fees associated with that.
Okay. Well, I certainly appreciate all of the details that you put in here. We got a little bit of the tech stuff. We got some user case stuff. You guys covered all the bases. I think that everybody handed out to you as far as questions, and I was really excited by this. I want to have a little bit of time to go back and rewatch it all when I can settle down and not watch the participants list and the chat list. But do you have any questions for our community as far as that goes? You've still got 60 people on here, or any final comments or anything?
I mean, the only thing that I would really, without having thought about this before, I lose track of the user community and just is this new to people, the fact that it exists at all? Are there people that are watching this that have never heard of Jupyter, that knew about Jupyter but didn't know you could run it as a service? I think that's where I would go for, is how should we be communicating this to people, that it exists, and should we expect that people already know about Jupyter, or should we be starting with literally nothing and this is Python and this is why you should care about Python? That would be where I would go. How about you, Brett? Do you have any questions?
Mine was just generally the audience. Did we hit our?
How did we do?
I think with the 60 people we've got still logged in, if everybody has access to the yes and no buttons at the bottom, if you got if this was worth your 1 hour's time, hit yes. And they're a little bit slow sometimes to get to the buttons. I expect, again, it's at the bottom of the participants list, if you guys can see it. So,
oh, I see.
Yeah, so, as they wind up, there's always a few that are kind of listening and doing something else at the same time. So it's, pretty much unanimous at that point. So I expected as much. This is the community that actually asked for the Jupyter talk. So I assumed that they would have a very specific interest in things, and I kind of expected that all be on the call today. So I think you guys knocked it out of the park.
Well, thank you. I will say, if you've used it kind of personally before, trainings really have been an excellent place to use it. And I don't know if Brett's had as much opportunity to see it used here in that way, but using Jupyter Hub for this, or for trainings, definitely beats going around and looking over everyone's shoulder to get them all terminaled into a machine. That was a huge win the first time we demoed that in a class, in a classroom setting, but not in an actual formal class. But yeah, thanks for giving us an opportunity to talk. We like Jupyter.
Yeah, this has really been great. I'm glad you guys did this. I apologize for asking for a brand new specific presentation, but I really think you're going to get a lot of mileage out of this now that you've got it put together. I think. Yeah,
Thomas has already asked us to give it somewhere else, and I forget now where that is.
Of course he has. Yeah, and I'll mention to Thomas that this went exceedingly well, in a few minutes. So he knows how things came out and everything, and we certainly appreciate it. If Brett, you and Jonathan, if you've got any other things going on at Boulder that would be of interest to this community, please send an email to Marissa and I offline, and and we'll keep you slotted up for other participations.
Cool. One thing I will comment on from the chat, someone says our IT didn't know about it until a faculty member, asked for a setup. That's been our general experience, is that users tend to already know this exists, and it's the service providers who don't. And so if you are at a site that wants to have, or if you want to have this available centrally, and your IT department needs help or encouragement getting it set up, feel free to send them to us. Like, this is not that hard to set up. And sometimes just having someone tell you it's not that hard, you don't have to worry about it too much, is all it needs. So I think for the amount of effort you have to put into it, it's a huge win to have something like this. So yeah, we didn't put our email addresses on a slide anywhere, but we'll share our slides out, and I'm happy to have our email addresses on there. Not that you can't find them on our website as well.
Is it okay if we, Marissa and I, put your email addresses in the email we sent out to the?
Yeah, that's exactly what I would expect. Yeah.
Okay, that's fine. We'll look for the slides, and we actually, and I'll copy you guys on this too. But we put these out on our YouTube channel, so this presentation will be available forevermore.
Excellent.
Bonus.
We certainly appreciate it, and we're at the top of the hour, so we'll go ahead and stop recording and give everybody, let everybody go to their next meeting. But Jonathan, Brett, we really appreciate it.
Thank you very much.
All right, thanks all.